Cool. So, hi, I'm Lauren, and today I'm going to talk about the evolution of a cybersecurity product, how the team and I went from command line to a production-ready cloud application. But first, a little about myself. I joined Red Maple last year in May, and since my first day, I've been technical lead on FractalScan, working, designing, developing, thinking every day and minute about it, and that's the tool I'll talk about today. So let's start at the very beginning. Our professional services team have been using a collection of open source intelligence and enumeration tools to build up a picture of a company's online estate and vulnerabilities. Naturally, us developers wanted to automate this and turn these bespoke tools and techniques into a product. So fast forward 1 year, and we have FractalScan Surface, an attack surface management tool that is available for free trial right now and uses all the fun buzzwords: scalable, hosted in the cloud, Kubernetes, single page app. And it was built with an amazing team of 6 engineers. So for some context, FractalScan Surface finds and assesses your online attack surface from a single piece of information, checks for configuration issues and security vulnerabilities, then summarizes this in an easy to understand score. It will even tell you how to improve your score. But we're not here for a sales pitch. You can find us at the end for that. We're here to go through how we did it. So we'll start at the beginning. We started with an idea and worked on a prototype. We were excited about the idea, and the last thing we wanted to do was learn new technologies. That would come later. So we started with what we felt comfortable with and was quick to set up. Our stack consisted of JavaScript, Node, MongoDB, and Neo4j. This was all in a single repo, just using command line, and there wasn't even a UI yet. One of the important things that we focused on at this stage was not to be too precious with our code. We knew it would kind of get refactored. It did mostly. It was just about collaborating and testing if the idea had any legs. And our code base has changed a lot in a year. But I think because we didn't have any expectations, that allowed us to experiment. So jump forward a month, there were a couple of us working on it full time, and we did have some interested parties. We had proved we could gather the information and had a very basic, I'd almost say ugly UI, but it was exciting to think about how it could look. There was a demo on the cards, and although the focus of the project was the information, how we gathered it, processed and analysed it, that wasn't what a potential customer was going to see. So we needed a new UI. And again, we reached for something fast and simple: an Express server using Bootstrap and Vue for the client. In a couple of weeks, we had a nice front end that highlighted the key points we wanted to get across in our demos. We knew this wouldn't be the finished product, but we wanted to have something we could take to people and get feedback. This was our stepping stone. Our next hurdle was balancing running everything locally on our laptops, because we wanted a working system available for our demos, but we also wanted to continue to develop new features, which often left our local versions in an unstable state. So having a deployed version was now critical, and not only because we wanted to be able to demo regularly, but also wanted to be able to allow the rest of our team and company to use it. So we went back to the whiteboard and redesigned the system to be scalable and deployable in a Kubernetes cluster. This redesign would require moving everything into separate workers, adding message queues, and refactoring a lot of the code that was duplicated in places. And to do this mammoth change, 2 new members joined our team at just the right time. But doubling the number of people in a team doesn't always equal double the productivity. We needed more structure, planning, and goals. We needed project management. So that's what we started doing. But this was quite hard because we were used to being able to do anything we wanted, and suddenly we had to seek approval and get everyone on board before starting a new idea. But our main focus but I found it was really important to have good communication and to be able to voice our concerns, because working in a team can be hard, but being able to communicate and adapt makes it a bit easier. So by October, we as a team were working well together, and we'd finished the initial refactoring, and we had 20 plus repos. This wasn't the ideal number. It was a lot to manage, but we took the view that we wanted a repo to equal a Docker container image pod. So when making a change, it would be simple to just trigger a rebuild of one pod and not the whole system. We did find that the monolithic repo was useful for prototyping, but we wanted to move to automatic deployment, and having a multiple repo pattern meant a push to main triggers a rebuild and deploy to production. Well, in theory, but we hadn't got that quite far, so it wasn't all hooked up, but baby steps. So we deployed FractalScan for the first time manually to our K8s, to our Kubernetes cluster, and for the first time other people could use FractalScan. It was a very exciting milestone. But the work didn't stop there. Going from running on our local systems to a cluster had a couple of bumps, one being performance. We weren't sure how much resource the different parts of our system would need to perform optimally, but we did know how it would perform on, but we didn't know how it would perform on large data sets. So it wasn't perfect first time, but being able to run the system in a production environment with large data sets was very useful in identifying issues. So we reassessed the system, found the sticking points, refactored, and then refactored again, making the system better each time. At the same time as this, we were planning and preparing for a beta launch. This is where we really had to start juggling and prioritizing requirements. We wanted to add unit tests and system tests. We wanted to add CI and CD, continuous integration and continuous deployment. We wanted to add more features, but we had to fix performance issues and we had to fix bugs. So in a perfect world, with an infinite amount of time and attention span, we would have been able to implement all of that, but we didn't have the time. So we implemented the bare minimum testing to make sure a change didn't majorly break it, and skipped over the continuous integration, continuous deployment. Though the tests we did implement gave us a good foundation, so that we could add more tests for each new feature and bug fix. I did find at this point that it was hard deciding what needs to be done now to get a product out there, and what needs to be done now to prevent a huge headache and outages in the future. And I think that's quite a hard thing to balance. And I'm not entirely sure if we've made the right decisions, but we've got a working product in the end. And at times it also felt like we were only preparing for users to use the system and fighting bugs instead of actually adding new features. But it was important to take this step to get feedback and confirmation that we're on the right path. So getting the system ready for users was important. And in February 2022, we invited our beta testers to log into our system. We decided to do a slow ramp up of beta testers, making sure the system could cope with increased number of users. We chose a range of beta testers. This included ones that would give the customer point of view, ones that knew what FractalScan was trying to do, and our own professional services team. This allowed us to get varied feedback which elevated FractalScan and gave us plenty of ideas for future features. Despite the new pressure of making FractalScan available, it was great to get feedback about the product we were all excited and passionate about. And the feedback was great. Having beta testers means that we shouldn't accidentally cause an outage whenever we release, but this did happen a couple of times. Most definitely were not caused by me. And it was also taking us like 2 hours to rebuild and deploy the whole system if there was a large change, which I mentioned previously, we didn't want that headache. So it was time to do continuous integration, and it was time to have a separate production and development cluster. So we switched to using Helm, and like everything else we've done in this project, we did it in stages. So we refactored the configuration to use Helm. Then we moved it to Helm, and then we set up our build and deploy to trigger when we push to main. And then we hooked up the system tests that we already had in place to our CI. Now it's time to add a dev cluster. So Because of the changes we'd already made, this was really simple. All we had to do was add a new config file for the development cluster and set it up to trigger on develop. So simple, we actually deployed on 2 different clouds. We were using GCP because that's where the Red Maple dev cluster is and where we did our first deployment, as we didn't need a separate cluster to start off with. But our development and current production cluster is on Ionis for a couple of reasons. Ionis is a European-owned company, so data held in their data centres is not subject to the US Cloud Act and enables FractalScan to be GDPR compliant. Ionis's CPUs are physical CPUs, not virtual ones like on GCP, so we get more compute power that isn't shared with others by default. And it's cheaper than using the GCP servers hosted in Europe. It was quite nice at this point because I felt a small weight lift off my shoulders. I could deploy changes to dev and check everything still worked together well, and then when I was happy with it, release to main. I didn't feel the pressure I had to get it right the first time. And I will say that bugs still have creeped into our production system, but we're not perfect and that will always happen. And it is quite a large system with a lot of moving parts, so it's nice to be able to test large data sets and edge cases, which are hard to replicate locally. So, we have a working product running in the cloud with an additional dev version available. What could be next? Turns out there was quite a few things that we had to do. Think about user management and how roles and features will work, define feature sets. We had to revisit our performance again. We were originally using a dedicated graph database called Neo4j, but we found that the queries and the performance that we needed just wasn't there, so we actually switched back to SQL. And then we've just been refreshing and revising the UI for a better user experience, and then working on system stability and testing. But we are in the final home stretch. So in the end, we have FractalScan, and it's exciting to think where we might be in another year. And I'll leave you with some final points that I've learned over the year. Prototyping code should not be expected to be production ready. Prioritising what needs to be done now versus later is a hard problem. Working with a good team really helps create a great product. Thank you for listening. Are there any questions? Yes?
If you get to a problem, how do you save?
What FractalScan does is it tries to find your attack surface. So it doesn't protect you. It tells you what your issues are so you can fix it. And it'll give you a score telling you how at risk we think you are. No. If you're on the internet, then no. Any more? Yes.
You said you were looking to deploy CI/CD for your pushes into production. How long does it take from when you do a main push to like the repos? Does the operational system be fully updated and ready to go?
It takes about 10 minutes if we deploy a change that affects all our repos. If it's one, it takes a couple minutes. And we can watch the stages go in progress. The nice thing with Helm is it actually checks it deploys to our Kubernetes cluster properly, and then it's up and running. So we don't have to worry about having to go and check another system. It'll fail in our CI and we'll get an email. I think that's us. Thank you very much.